Okay, so what did we do so far? Well, we did output, we did input, we talked about what comments are, what variables are, and today what I'm going to do is I'm going to start you with selection. Okay, so what is selection? Selection is a way for us to do one of many things, right? So for example, let's say you have this piece of code, and if I wanted to run this thing, this is lecture, what's today, 9. Okay, so if I ran this code, from what you have learned so far, it shouldn't be a surprise that this is what shows, right? Okay, but we don't want everything to show, right? Obviously the age is 25, whatever that variable is, so we only want to show a certain message, right? So which message do I want to show? Okay, that makes sense, right? You're over 21. Okay, so how am I going to do something like this? Well, I'm going to use something called selection. So, for example, I'm just going to do this. If age is less than 18, I'm going to do this. If my age is bigger than or equal to 18, and then inside there I'm going to have another if my age is less than or equal to 21, then I'm going to do this one. You want to indent these, okay? So how much you indent, it doesn't really matter as long as it's consistent. Okay, so if I want to have multiple prints, they just all have to be indented under the same thing. Okay, so same distance from the wall. So if it's one space, it's one space. If it's 4 spaces, it's 4 spaces for all of them. Okay, so this here is an example of a nested if. Nested if, which is just one if inside of another if. This one here, this one is going to be over 21. So if my age is greater than 21, I want to do this piece of code, and I'm just hitting the tab every time. Okay, and then this last one is, I'm just going to take it off for now, right? So let's just see if this works. If I run the program, yeah, it shows me you're over 21 years old. If I go in there and say, okay, well, let's check for like 6, run that. Then it shows you you're under 18. Okay, great. Let's try to give it like a 20. All right, run this. And it gives you that one, right? So how does an if work? Well, this piece here gets checked to see it. The computer can check to see if this is true or false. Okay. So this is a Boolean expression, and it's also known as a condition, right? So condition means the computer checks if this is true or false. Okay, how does the computer know to see if this is true or false? It's built into the processor, right? The processor has 2 pieces of it. One is the arithmetic logic unit, the other one is another unit. Okay, the arithmetic logic unit is, as it says in the name, can do logic. What kind of logic? Like this. It can check to see if something's true or false. Okay, how does it check to see if it's true or false? Using these relational operators, right? So if I go in there, let me point this out to you, right? That's an example of relational operator. Okay, so these are used inside of conditions. What's a condition? Well, you have something and you're checking to see if it's less than, greater than, equal, not equal. Okay, so if I was to write you a summary of the relational operators, right? The relational operators are less than, greater than, less than or equal, greater than or equal, equal, and not equal. Right? These are my relational operators. Right? One more time. Less than, greater than, less than or equal, greater than or equal, and the not equal. The not is with just an exclamation in front of the equal sign. Okay? Don't confuse the double equal with the single equal, right? This one here is check to see if something is equal, right? Don't confuse it with this one. This one makes something equal to something else, right? So if I went in there and I said, just like I'm doing here, age is equal to 20, it makes this equal to that, okay? All right. So these are my relational operators, and with the relational operators I can build conditions, and the computer knows how to check these conditions to see if they're true or false, okay? So the conditions again, conditions would be, if I went in there, let's say conditions will be basically you get these, right, and you put them between some kind of a variable, right? So a condition would be, let's say I'm checking to see if x is less than y, or I'm checking to see if, you know, x is greater than y, okay, and or x is less than or equal to y. And I have all these written to you on the class webpage with more explanations, so I'll show you those in a second. Okay, so these are my conditions. We build those with the relational operators, and with that we can do selection, which is done using, for now, what you've seen, ifs. Okay, so let's see what else do I want to tell you. Okay, so for example, let me just show you what happens if I was to go in there and just do this. I'm going to say, all right, print age is equal to 20, right? And then in here, I'm just going to say age equals 20. I don't know if it's going to work. Let's try to see. Yeah, it works. All right, so right here it tells you age is equal to 20. That's true, right? So I'm going to put a little is in there. Is true. Okay, so next is, I'm going to show you the rest of them, just so that you can see that when I do this, the computer can figure out if something's true or false, right? In here I'm going to say, okay, greater than or equal to 20. What is that going to give me? Is that a true or false? Huh? Come on. Is 20 greater than or equal to 20? Yeah, okay. So hopefully, maybe I'm wrong. Let's see, run it. Right? So it's a true and a true. Okay, so they're both true. Let me resize. Question? Yeah, please close the door. I was going to ask that. Okay, so keep going. Next one. Let's say not equal, right? Is 20 not equal to 20? You got to help me. I don't know. Is 20 not equal to 20? If you don't know, run the program. That's a false, right? 20 is equal to 20, so the 20 not equal to 20 is a false statement. Okay, false. All right, and what else do I have? I have less than or equal. So I'm going to go in there and do less than or equal, and you tell me, is 20 less than or equal to 20? If there is an equal sign in there, then that's true, okay? So actually, this is true. Run it again, just to double check. There's your true, okay? What else we have? Equal, greater than or equal, less than or equal, and then there's also the greater than and the less than. So let's test those out so you can see what it shows. All right. So this one is going to be less than, this one is going to be greater than. All right, and are both these true or false? You all paying attention? Is 20 less than 20? No, right? Is 20 bigger than 20? No. Okay, check. That's the best way to, find out. Just run the program, right? When in doubt, type the code, run the program. That's the easiest thing in the world. Okay, so they're both false. So this is how you build conditions. You have to understand these. You have to know the difference between less than and greater than. That's what, the more math challenged people have a hard time with. But don't embarrass yourself. You should know these, right? These are the basics. And if it doesn't make sense, just type up the code, run it, see if it works, see if it shows you true or false. So this is false, this is false. Okay? All right. So these were my Boolean expressions, right? So this is basically Boolean logic. Boolean logic means, Boolean logic is this kind of stuff. When you're checking to see if something is equal to or not equal to, right? Something can be either true or false, 1 or 0. That's what really drives the computer. That's all it can do, really, right? So based on these simple rules, we can build very complicated things. And I'll expand on this. Okay, so I showed you a couple ways to do things, right? So far I've just shown you the if, and what I'm going to do now is I'm going to do some other things. So let's say in here I'm going to rewrite this so that it works the same but different. It will be written in a different way. So if I do this, so rewrite the above using an AND. Okay, and it goes like this. If my age is greater than or equal to 18 and my age is less than or equal to 21, then I want the same thing to happen. All right, I'm just going to copy it, paste it in there, and for an age of 20, right, both of these ifs or both of these better get triggered. So this should show up and this should also show up. And if I run it, yeah, sure enough, there it is. Okay? So an AND is another way to have basically a nested if statement. As far as this, the way this particular, these two pieces of code work, it does the same exact job. Which one would you do? Well, probably the AND. It's a little more condensed. It even makes more sense. So whenever you're writing your programs, just think about things logically. Like the way you would think about something. It's like, all right, I'm going to grab the door handle and I'm going to press it down, and then I'm going to push. And if it's unlocked, the door's going to open. And that's how you write programs. Okay? As long as it makes sense in your head, you can write the logic in the program, same exact way. Any questions? Pretty basic so far. All right, so this is the AND. The way an AND works is for an AND, both conditions must be true. That means that this one must be true and this one must be true in order for the whole thing to be true. Okay? If I have a false here, let's call lowercase false here, and a true here, then this whole thing is going to be false. And by the whole thing, I mean this, right? So if this whole thing is false, then this is not going to happen. Just like if this here was false, we're not going to go in here, and if this here is false, we're not going to go in here. Okay? So both of them have to be true in order for this to be true, and you could have a false and a true. You can have a true and a false here, and this is also going to be false. And of course, if you have a false and then another false, then this whole thing is going to be false also. So the only time it's true is when both of them are true. Okay, so that's your truth table of an AND. Okay, and the AND is known as a logical operator. Okay, that's a logical operator. So we had conditions, we had relational operators, now we have logical operator. Okay? So far so good? Make sense? Again, it should make perfect sense. But once you start writing these, you're gonna encounter some difficulties, and that's really the only way to do this is hands-on. You gotta get your hands dirty. I can talk all day, and in 5 minutes you'll forget it. Okay, so I have this little invalid age going, and it never showed because I commented it out. But what I'm going to do is I'm going to now mess with the age. Okay, so I'm going to take off this here because I don't want to keep looking at it. All right. And let me just run the program one more time just to make sure that it works. Okay, so it works as is. So now what I'm going to do is I'm going to go and let me just move this age. Actually, I'll add another age right here. So age now is equal to -10. Okay? So obviously -10 is not a very good age number. How can you be a negative number unless you're like born in BC or something? So anyway, there was like a really good joke about, never mind. Basically how how we all count ages based on Christianity, and how somebody was, let's say, when you're like if you were at 3 AC and somebody was like 28 years old, like how do you work out that math? Anyway, watch Louis C.K. Anyway, we can't really have a negative age as far as we're concerned. So what are we going to do? Well, what we're going to do is we're going to give it this invalid age. All right, so I go in there, invalid age. Okay, so the invalid age is going to be, well, actually, let me just run this thing to see what it looks like. So if I run this, it tells me you're under 18 years old. Okay, sure, if the age is negative, you are under 18 years old, but it's also an invalid age as far as we're concerned. So I'm going to do something like this. I'm going to say, okay, if my age is less than what value? Great, right? If it's less than 0, then I'm going to say you're invalid age. Okay, I'm going to run this thing, and it shows me this is an invalid age, but it also shows me you're under 18 years old. I don't want the second one to show up. Okay, what am I going to do? Well, that's where the else if comes in. Right? And Python got really lazy, so they didn't call it else if, they call it elif. All right? So if the way an elif works is an elif only gets checked if the previous if or elif is false. All right? So only if this thing here is false am I going to go check this. So the age must not be less than 0 in order for me to even look at this. If the age is less than 0, we stop right here. Right? So stop right here. Don't even check this if the age is less than 0. And I'm going to go and do the same thing for all the other ones, right? Because this is an example of an elif chain, right? So the way it works is it stops at the first one that's true, right? So if this one happens to be true, we're going to show this message and stop here. If this one happens to be true, we're going to show this message, we're going to stop here. If this one happens to be true, we're going to go in there, and if this happens to be true, we're going to show this. Okay, question? Yes, sir?
Just to clarify a little bit, if you left those bottom two ifs as ifs, it would check those as well, even though it wouldn't do anything because it's not part of it, right?
You mean like these two here?
Yes.
Yeah, if I had it like this, checks this, and if this is false, if this is true, it won't do this and this, right? But then, yes, it will continue, it will do this, and it will do this. By doing it, it will check them. Okay, yeah. And that's where you have to kind of be careful, because sometimes if I say maybe, well, if this, and then if that, then some weird things are going to happen. So it's basically, if my age is bigger than or equal to 18, right? Which it could be. Let's say I'm going to go in there. I'm going to say age is 20. No, I got to do less than that. Well, put it this way. You could have basically, if you have an if and an elif, you could make this piece of code so that it didn't really work exactly as expected originally, because it will stop at this one, even though necessarily if this is false, right, then that will turn off this piece of code altogether. Right there, elif. Okay. So I'll let you run into these problems as you write your code. That's the best way to really realize what I'm telling you. Okay, but for now, just remember that if we have an if-elif chain, where it stops is at the first one that's true, right? So I'm going to go with the -10 here, right? So this is an if-elif chain. You stop at the first condition which is true. All right, let's keep it simple. So does that make sense? Okay. So let's run this piece of code. Hopefully it will show me this is an invalid age and nothing else happens. Maybe the program won't work, who knows? Oh, there you go, it's an invalid age. All right, now let's do the same thing with the, let's go with a really big age. And that kind of brings me to another stupid story. Do you know what's the oldest documented human being in the world?
Lucy?
Hmm?
Like some really old woman version
Hmm?
human being called Lucy.
No, it's not Lucy. But let's just Google it, because it's awesome. Oldest documented human being. All right, we're not going to count Moses because nobody lives up to 400 years. We all know that. Oldest people. Where's that? There she is. So her name is Jean Comment, and she lived. These are people with actual documented, birth certificates. As far as we know, they're not forged or anything. So she has her birth certificate. We could prove that she has lived 122 years and 164 days. Okay? But that's not the interesting part. Guess what she did until she was 119? And I'll give you a clue. Right? So the oldest documented human being smoked every day until she was 119. Guess why she stopped smoking? It wasn't for health concerns. She was too blind to light up her cigarettes, and she hated asking other people to do it for her. There you go. Okay. She also ate tons of chocolate when she got hold of it. She drank red wine every day. All right. So there you go. Now you know the key to longevity. But because of her, we know that, let's say the limit is going to be 123 years. All right. So let's go in there and we're going to do another one. So I'm going to give a 124. Right. Too old. Let's make it older. Let's go 300. Let's go Moses years. So we're going to go in there. I'm going to do another one. I'm going to do something like if age is bigger than, I said, 123, and I'm going to make this other one here elif also, because if it's an invalid really big age, why would I even bother checking to see if it's an invalid negative age, right? So elif again. And this time I'm going to say, again, invalid age. I'll just keep it at that because I'm trying to make a point that comes up in a second. Okay, so if I run this thing, hopefully it'll give me an invalid age and it stops, which it does. All right? Okay. Any questions up to this point? Where do we get her birth certificate? I don't know, somewhere in France. So notice that I wrote the same piece of code twice. This is an invalid age. This is an invalid age. Okay? You know I don't like to repeat things. If I can, kind of summarize my code, I will, and I will. So what am I going to do is I am going to rewrite. So rewrite. By the way, notice if I am inside of an if or an elif and I hit the enter key, it automatically lines it up as it should be, right? If you have something weird going on like that, notice what happened? It didn't line up. It's because the previous line's messed up. That's your indicator. Okay, Python really cares about indentation, so I'll mess up the indentation for you to tell you that something's wrong. Okay, so that's what it is. So I'm going to go in there and I'm going to rewrite the above using an OR. Okay, an OR is another logical operator. Right? So you have an AND, you have an OR. Those are your two logical operators. So then I'm going to go in there and I'm just going to write the same thing. So if my age is bigger than 123 or my age is less than 0, right, I'm going to do this one message. Right? And what I'm going to do is I'm just going to grab this here. Maybe I can turn it off. I will turn it off. There you go. Okay, so I'm turning off this piece of code. Now, hopefully, this should catch a really big age and a really small age. So let's test again for a 324, invalid age. Let's test again for a negative number, run again, invalid age again. Okay? So yeah, it worked the same. How does an OR work? I got to tell you that. So the OR works, it needs to have a true, right? If it just has one true, you got a true. If you got two trues, you still got a true. Okay, so if you have a true and a true, how did I write on here? Yeah, if you have a true and then another true, this comes out to be true. Okay, if you have a true and a false, guess what? That's still a true. Okay, if you have a false and a true, that's also true. And if you have a false and a false, that's the only time this is a false. Right? So this one's true for any time you have a true in there. And by this one, I mean this whole thing here, right? So you have a condition, logical operator, another condition. So the whole thing is true if both are true, one is true, and it's false if both of them are false. Okay? Make sense? That's your truth table for the logical operator OR, right? And you have a truth table for your logical operator AND. You already learned what a Boolean condition is. Boolean logic means checking to see if something's true or false, right? A condition was like these things are the actual conditions. That's where we check to see if something's true or false. And we have a relational operator in the middle that lets you do that, right? And the computer's processor's CPU has the built-in capability to do these kind of basic arithmetics and logic checks and Boolean logic. Any questions? Let me see if I want to tell you something else. Okay. Python has some other built-in operators, logical operators, which are not really, they're not part of other languages. Well, let me just show you what I mean. So, for example, the not. Yeah, I already showed you the not, how the not works. Okay, so there's another version of the not. Okay, so this is not, but if you're checking to see if something's not equal to something, right? There's another not which comes in built into the Python language, which lets you work with more complicated things like objects. Like, for example, I can check to see if something's inside something, inside of a group of things, right? So one of the Python built-in data types, which I introduced briefly in one of the example programs you had to type up, was a list, right? So let's say I'm going to make up a list here. So a list is equal to just 1, 2, 3. That's a list of 3 numbers. I can have B list is equal to A, B, C. That's a list of characters, right? So you can have a list of numbers, you can have a list of characters, you can have a list of lists. List of lists is equal to A list and then B list, right? Other languages don't let you do these kind of things. Python doesn't care, okay? So in Python you can even have mixed types. So I can go in there and I can say C list is equal to, I'm just going to get lazy, copy this piece there. And then I add all the other stuff after it. So I can mix them, no problem. In other languages, these are known as arrays, right? Why did the programmer get fired? Because he didn't get a raise. Or why did he quit his job? He didn't get a raise. They always get the joke wrong. So anyway, you need to understand this because it's like one of the most important things that you're going to learn. Other than these selection and conditions, this is one thing that's used all over the place, and I'm just introducing it earlier. So it's just a list. So these are just different lists. Let me show you how do you show a list. Print a list. Print B list. Print C list. And maybe I should put some labels in there so you know what you're working with. Always put labels. Don't just throw things out. Just label what it is. There you go. This is my A list. This one's going to be my B list. All right, and there's let me just copy the whole thing. So this is your C list. Just the early introduction of lists, right? We're not going to touch lists for a little while, but as soon as I introduce loops, we're going to start playing with those. And this is my list of lists. All right, now let's see what it shows you. So if I run this, ta-da! All right, this is your first list, this is your second list, this is your third list, and then you have a list of lists in there. Okay, so what's a list? Well, you have some square brackets, right? And then you have different things separated by commas. All right, that's a list. That's basically it. Okay, later on I'm going to tell you a little more about lists, but for now, that's where I'll leave it. Okay, so what is cool about Python? It comes in with some really useful things that are built into the language, and you can just use them right out of the box. And some of them are like, say, all right, I can say, check this out. So I'm going to go on the bottom. I'm going to say if A is not in, or let's go with capital A, because they're different, right? If A is not in B list, right? I'm going to say print A is not in the list. Okay, and I'm going to do another one. I'm going to say if little a is in B list, then I'm going to show you, well, A is in the list. Right? A is in the list. Okay, so let's put it in quotes, is in the list. Okay, so I'll run this thing, hopefully it works. Yeah. That should have been a lowercase a. One more time. Right, so big A is not in the list, little a is in the list. So this not business and even the in, these are like extra built-in logical operators that come into play when you work with, multiples of things. Okay, for single things, you use these relational operators. Okay, so just a quick introduction for these extra ones. You're not going to have to use these until we get to lists, and we're not, first we're going to have to do loops, and then I'm going to show you lists. So there's time, but I just wanted you to get a taste of it because you're going to have to work a whole lot of it with it. Okay? Any questions? So not is another example of a logical operator. So this here is a logical operator. All right? Not to be confused with, what is this code? Relational operator. Okay? You better know the terminology, okay? Very important. Like, so there, remember, I don't expect you to memorize things, but the terminology you have to memorize. Right? You have to know what an integer is. You have to know what a relational operator is. You have to know what Boolean is, what a condition is. What's a selection, right? These things, the terminology itself you should understand because it's going to pop up in the program errors. It's going to tell you, oh, you forgot to declare a variable, or you forgot to initialize a variable. What does it mean to initialize a variable? Well, here I'm giving, this is initialize the variable age to the value -324. Right? So there's terminology in there that you should know. And sometimes maybe I'll forget to mention every single one of them, but you encounter it in the program, and then you're going to tell me, hey, wait, what does this mean? And I'll explain it to you one time, two, three, four times, and eventually, hopefully, you get it, and it makes sense. And debugging these programs takes you as quickly as it takes me, which is not very long. Okay? So, question?
Yeah. So if you were asking a user to input an age, I know in Bash that immediately below that you have to put read input. Do you have to do that?
Okay, let's change age to an input. So the same way that I just did this here, right? I'm going to go in there. I'm going to ask the user. I'll leave it there. I'm going to ask the user for input of age. All right, and you help me with that. So I just go age is equal to, what kind of data type is age going to be? Integer makes sense. Input, please enter age, and maybe I should be nice to the user and tell them between 1 to, well, let's go with the zeros. You could have a 0. 0 to 123, right? That's a valid age. And if they mess that up, then we'll do something. Okay, so if I run it, oops, invalid syntax. Okay, so notice how it's highlighting the syntax here. Is that where the error is? What did I forget? Remember, if
Second set of brackets.
second set of brackets, it's usually if it isn't the line where it's pointing at, it's usually the one above it. Okay, so I'll run again. Please enter an age. Now it's stopping to ask me, please enter an age between something and something. All right, I'm just going to go with numbers and an integer. Remember, because if you have an integer input, the input has to be an integer. If I give it a float, it gives you an error. If I give it a string, it gives you an error. So I go in there and give it a -1. All right, this is an invalid age, which is what I wanted to get. Okay, does that answer your question?
Yeah, so you don't have to put read like explicitly, it just does it.
No, it's just input. Remember, input in Python is input. There's no read. Yep. Okay, so this, right? So this is just a simple, simple something. Let me just do. Turn off these lists here and the complicated not, a little more complicated not. Right, and what I'm going to do now is I'm going to give you an example of input validation. Right, because I think maybe that's why you're asking. Maybe that's where you're going. So let's say they give you a negative age, and you don't just tell them, hey, it's a negative age, it's an invalid age, but you tell them, no, give me a good one. Okay, that's an example of input validation. Okay, so input validation, let's just say that is a check to see if the user entered valid input, right? So we know the age must be between whatever we said. So I'm just going to go in there and do an if here. All right, just do the same thing. And in here, I'm going to tell them the same thing I did. This is an invalid age. And the next thing that I'm going to do is I'm going to ask for another age. All right, so input or int input, let's just copy it because I don't want to write it again. Get this. And I'm just going to ask for another age. Okay? So I'm going to run this thing, and it should give me 2 error messages. It should give me this first one, right? That's the first if of this elif chain, and then nothing else in this elif chain is going to happen. And then I'm going to have another if, so it's going to have to check this thing all over again. And sure enough, it's the same thing. It's going to give me another error message, but in this one, it will also ask me to enter another age. So I run it. All right, negative age, -9, nope. So it gives you the 2 error invalid from the first if, and then there's another one. This is an invalid age, and now it's asking you for another one, and then hopefully you give it right this time. Okay? So realistically, that's not how you do input validation. The way you would do input validation is you would actually change this if to a while. But we're not there yet. All right? Just giving you a little taste. So what's the difference between an if and a while? The while is going to repeat over and over and over and over and over forever. Okay? So if it's a bad age, it will keep asking them for this and then asking them. If they give it another bad age, it will go back again and again and again and again. As long as when they give it a good age, right, then it will kick out of this loop. Right? But we're not doing loops yet. We're doing ifs. So baby steps. This is how you do input validation for now. Okay? Questions? Okay. Last thing I want to show you for today is random numbers. And the reason I'm going to show you random numbers is, all right, so there's examples in there with all the things I told you about. Oh, before I get into the random numbers. All right. So I've had a lot of questions in there and you know, most questions are not stupid. So I went in there and wrote all the different, you know, kind of questions and answers over the years. So trust me, for now, just any question is good. All right, so first of all, different scenarios for an if and elif, right? So the obvious one is, let me zoom in a little more maybe. Still not big enough, but whatever. Okay, so the first one is, you know, these are things of examples of things you could do, right? So you could have an if, and then you can have a print in it, right? And by the way, I don't think I showed you any examples of multiple things, but in here you can say print UR, and then close this one, print, and then I do another one, right? So you can have multiple things inside of an elif or an if, and just make sure that, you know, they all line up the same distance from the side. They're all indented the same. Okay, so different things you can do. You can have an if with something in it. You can have an if with another if in it, and then something in that one. That's an example of a nested if. You could have the if and an and, right? You saw that. You can have an if and an or. You saw that. You could have just a bunch of ifs right after each other, right? No problem. You can have your if-else chain, right? The if, elif, oh, and there's an else at the end. I didn't tell you about the else, but I will. Okay, so the if chain basically stops at the first one that's true. What is the else? Well, notice it's basically like an elif minus the condition. So when does an elif happen? The elif only happens when the previous thing is false. So if this is false, this will get checked. If this is false, this will get checked. If this is false, this one will automatically do this. So the else automatically happens when the previous thing is false. Yes? Questions? Make sense? Okay. All right. And you can have an if and an else. You don't have to have an elif in there. So as long as you have a single if preceding it, you can have an else, no problem, or an elif. Okay? All right. So, see, these are some of the things that you can't do. All right? So some of the things you can do is you cannot have an else by itself. Right? So I can't. Let me just give you some examples. So let's say I'm going to go in there and I'm just going to go all the way at the top. Right? So if I do if, well, let's just do it after this one. So I'm going to do it right here. So let's say I have if age is equal to 20, right? And then print 20. Okay, so that's one way you can do that, right? You cannot do elif to begin with, right? So first thing you can't do is start with an elif, right? Like this. And if you do, you're going to get a bug. You're going to get some kind of an error, invalid syntax. It won't even tell you what it is. Okay? So those are some of the nasty ones. It's like what's going on? What happened with my code? I don't know. Invalid syntax. Where is it? It kind of points to it, but let me click away from the line. See if it goes to it. No, it does. So it moves the cursor so it blinks where the right place is at least. Okay, so you can't start with an elif. So if you think about it, then you should not even be able to start with an else, right? And that's also not allowed, right? You can't start with an else. No good. Okay? Some other things you can't do, right? This stuff also applies when you're inside of, where's your nested if? See the nested if? Elif and then another if? Okay. So if I go in here and change this here, see how I'm starting with an if inside of the nested, inside of this elif, I'm starting with an if. If I started with an else, I'm going to get the same bug as before. Okay? If I start with an elif, I'm going to get the same bug as before. So once you go inside of an if or an elif, your next, chain of ifs and elifs has to start with an if first. Okay? Make sense? All right. What else? So, else. If you have an else, if I go in there and I say, all right, else, even if I have an if, let's say if age is equal to 20, print something, and then if I have to, if I go and I do this, that's a bug. Why? Because the else does not have a condition, right? If you run this thing, it will again give you a bug. Let me show you. All right, I run this thing, and invalid syntax. Okay, it doesn't tell you what's wrong with it, but okay. And what's wrong with it is, if you made this an elif, no problem, right? But the else itself cannot have a condition. Okay, make sense? Any questions? Okay. Last one. Last but not least, right? If I go in there and I do if age is single equal 20, what am I doing? I'm actually making this equal to this, but that's not a condition, right? So hopefully it gives you an error, and it does. Okay. Some programming languages like C++ won't give you an error on most of these things. Okay, it's like the most unforgiving language after assembly. Okay, so something like this, your program will actually run, and then it's just not going to work the way you want it to, right? It's because it will make age is equal to 20. So Python is actually doing you a favor by giving you these extra errors. The more errors you get to begin with, the less errors you're going to encounter as your program is running. Okay, so the runtime program bugs are usually harder to figure out. It's harder for you to figure out the flaw in your logic than it is for you to figure out, oh wait, there's a missing double equal sign. Okay, so these syntax errors are what we're dealing with this. The compile time errors, same thing. Okay? So I think that's all I can tell you about selection. Okay? And I have one more thing I want to tell you. These arithmetic operators, the multiplication, there's a way for you to do power, right? If you want to do, say, x to the power of 3, you do x asterisk asterisk 3. This is how you do the power in Python. Just in case you want to know, because these are the arithmetic operators. Since I showed you the logical operators and the relational operators, I figured why don't I throw in there the arithmetic operators. And there's also the plus and the equal and minus and all that stuff. All right, so modular. So I should tell you about the modular. It's a good time to explain to you about the remainder operator. All right, so let me throw that in there for today. So, and I'm gonna throw this all the way on top. Oops, age is equal to 20. Maybe I need that. I'll leave it there. Okay, so let me show you what the relation of what did I call it? The modular or the remainder. Okay, so this is the percent. They call it modulo, they call it modulus, they call it the remainder. I don't care what you call it, right? As long as you know what it does, I'm happy. Okay? Again, you should know what each of these refers to the little percent thing. Okay, and you should know how the percent thing works, so that if you ever encounter a bug that tells you something about the modulus, you know there's something with the percent. Okay, so we have encountered the percent so far in our print, right? So when you do print, what do we have? Age is equal to percent. I can do an S for everything for a string. Anything can be a string, right? I can just say age. So when I do this, it shows you age is equal to 20, right? So that was the one meaning of the percent thing that we have encountered up to this point. But that's not what the module is at all. Okay? So completely different meaning from this one. And let me show you. So let's say, for example, and I'll just give you like a little introduction for this. Let's say I'm just going to try to do prints in there. Okay? So just plain prints. So print 4 divided by 3. Let me see if I can do that just right in there. Yeah, I can, right? So 4 divided by 3 is 1.333, right? That's this one. Okay, let me go in there. Let me resize this a little. put it up there. All right. Maybe a little more. All right, leave it there. So the next thing is, let me go in there and do something else. I'm going to go print for modulus 3, right? 4% sign 3. Just to show you that it's not the same thing, right? This is not how you divide numbers. This is the remainder operator, right? So this one here shows you this. Let me see if I can throw them in there. Nah, it's not going to work probably. Now I'll leave it like that, right? So this one shows you the 1.333. This one shows you 1, right? Let's go another number. I'm going to go print little divider in there. Okay, so I'm going to do print 5 divided by 3. And then I'm going to do print 5 modulus 3. Okay? And have a look at that. So 5 divided by 3 is 1.667, right? And 5 modulus 3 is 2. All right? And you're probably getting annoyed because you don't know how this works yet. Right? How are we getting these numbers? All right. So this number here is, the way we get to this number is, we ask the question, how many times does 3 go into 4? How many times? Once, okay? So 1 time, right? 1. So then you go and you do, okay, 4 minus 3 times 1 is equal to 4 minus 3, and that's the 1. All right? So same question we're going to ask for this one here. How many times does 3 go into 5? 1 time, right? Still 1 time. So you go 5 minus 3 times 1 is 5 minus 3. All right? And that's a 2. All right? Let's do another one. So I did the, for 4 modulus 3 it's a 1. For 5 modulus 3 it's a 2. Can you guess what it's going to be for 6 modulus 3? 0. Excellent. So the question is, again, how many times does 3 go into 6? How many times? Twice. 2 times. So I got a 2 in there, right? So then I go, all right, 6 minus 3 times 2 is my 6 minus 6, which is your 0. Okay? Let's go one more. This time I want to go and I want to do 7 modulus 3. All right? What's my remainder now? We can ask the same question again. All right? How many times does 3 go into 7 this time? 2 times, right? 3 times 2 is 6. This time you have a 7 in front. 7 minus 6 is your 1. Okay? So the one thing that I want you to notice is that you could have a very big number here on the left, right? Doesn't matter how big that number is. But the remainder, what comes out of it when we do modulus 3 are the numbers 0, 1, right? This was a 1, 0, 1, 2, right? So in general, I can say if I went in there and I did, let's say, print, I don't know, that, okay? And I want to do modulus 3. Can you predict what number is this going to be without doing any math? It will be either 0, 1, or 2. Those are the only 3 possible numbers that I'm going to get. So I can go and I can rotate from the numbers from here from 0 to infinity, or, and I'm always going to just keep getting these 3 numbers, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Okay? Make sense? So this here, the modulus 3 tells you we're going to have 3 numbers. and the three numbers are going to be 0, 1, 2. That's it. So if I went in there and I did something like the numbers, so the numbers, the remainder for modulus 3 can only be these three numbers. Okay? So, and I can prove that to you, right? So I'm going to go in there, I'm going to do this a couple of times. All right, I'm just going to rotate a few numbers. So I'm going to go this. So let's go 0. Let's go 1. I'm not even going to do 0. Let's go like 4. No, let's do 7, 8, and then this last one is going to be 9, right? So I'm pretty sure this one's going to be the 0, this is going to be the 1, and this one's going to be the 2, or no, this is 1, 2, 0. Let's see. 0, 2, 1, right? 1, 2, 0, that's what I was saying. Right? So the 0 is because 9 is evenly divisible by 3, you get a 0, right? So this one is a 0, this one is 2, and this first one was a 1. Right? So it doesn't matter what giant number I throw in front of the modulus 3, right? I'm always going to get these three numbers, 1, 2, 0. Right? Okay. The 0 indicates something. And that's I'm not going to take it any further than this, but I'm just going to tell you something. This modulus thing that I just showed you right here is what's used in encryption. It's known as hashing. It's basically you get a giant set of numbers and you reduce it to something smaller. And there's no way for you to go from the smaller back to the giant set of numbers because you don't know what the hashing is usually. And the hashing is this little piece here. Right? That comes in later, much, much later. For now, and by much, much later, I mean when you finish this class and you go take your next Java class, and then you take your C++ next class, and you still not have encountered that, then you're going to go take the data structures class, which is the last programming class you take here, and hopefully there they show you what hashing is. And if they don't, come take my classes at Gavel and I will. Okay? So, this is, and by the way, hashing and encryption and all that stuff, those are the questions that are going to pop up on interviews and stuff. One of my top students at Gavilan, he just came from a job interview and they asked him to write a hash function. Better know this kind of stuff and data structures in order to get to that. Okay? So anyway, bottom line is, if num modulus x, right, I'm going to put it in there on the bottom. So if num modulus x is equal to 0, right, this tells you that num, all right, I'll put it right here. This tells you that num is evenly divisible by x, right? So this giant number, if it is evenly divided, there's no remainder, right? Just like the 6 here. 6 is evenly divisible by 3, which is why the remainder is 0. Okay? This is not evenly. This one here is not evenly divisible. The remainder is not 0. This one here is not evenly divisible because my remainder isn't 0. This one is. Right? This one here also is. How did I know that it was evenly divisible? Well, I know that the last piece here, the 9, is evenly divisible by 3, so that tells me. Okay? Where does this come in handy as far as you're concerned? It comes in handy because I'm going to ask you to do things like check to see if a number is odd or even. Right? So now that you know all this stuff here, let me go all the way at the bottom. So first, a little introduction for what the modulus is. Right? And how it works, and that it's used in encryption, and that, basically you should remember this, right? So I'm going to copy this piece, right? So if num modulus x is equal to 0, this tells you that num is evenly divisible by x, okay? So how can I find out if a number is odd or even? How can I find out if a number is odd or even? Right? And let me just give you some. Right? So these are the even numbers. Let's go with 2, 4, 6, 8, 10, 12, right? Any number that can be evenly divided by 2 is an even number. All right? So you help me write, let's say I'm going to have num is equal to something. Right? And I want to check to see if num is even. All right? What do? I write if num modulus 2 is equal to 0, I'll tell you print the number is even. All right? Is this number even? Why don't I go ahead and ask the user to enter some number too? So that way, I can do it int input, and by the way, it has to be an integer, right? Please enter a value. All right? And I'm going to run this thing. That's the age from before, and then please enter a value. I'm going to go with 1. Doesn't show anything, right? Why don't I go in there and add something for an odd? So if this thing is an even, then I can do another one. I can say, all right, if num modulus 2 is not equal to 0, then I'm going to give you the other message that it's not even. It's not even. And I can even show you the number. Well, I'll leave it like that. So the age from before, and then let's do an odd number again, and the number is not even. Okay? So this is how you check to see if a number is odd or even. Any questions? Pretty easy. Okay, you can use this thing to check to see things like, well, is it every 5th year, or is it every 10th line? That kind of things, right? So if you're counting sets of things and you want to check to see if it's every so many, that's when you can use the modulus, right? And then you can use it for hashing and all kinds of other things too. All right, so that's the modulus operator. I wanted to show it to you because, well, you need to know how to check to see if something's odd or even. I'm going to ask you that all over the semester, so you better remember it, right? So it's just basically a practical application to the modulus operator. I'm going to hammer it until it sinks in. Okay, so last thing I want to tell you is about a random number. Okay, so what's a random number? Well, in Python, it is very easy for you to make a random number. Let's say I want to make a random number between 1 and 7, or let's go 6. Okay, first thing I want to do is I have to import random, or actually let's make it simpler. I'm going to say from random import randint. Okay, what's random? It's some library. It's another file that exists into the collection of files of Python, and in that file there is something called randint, a function called randint. Okay, you don't know what the function is yet. Okay, what you will eventually, but today you're going to learn how to use a function. You have actually been using functions. Input is a function, print is a function. What's a function? You have something, and then you have parentheses, and then maybe something in quotes, right? The something in quotes is a definite maybe, because you don't have to have that. Here's an example of another function. So I'm going to say, all right, I'm going to say random number, that's a variable that I'm making, is equal to randint, and I said I want it from 1 to 6. So randint is my function, and I'm sending in 2 things into it, telling it generate a random number from 1 to 6 for me. Okay? Is it going to do that? Yeah. Print random number equals random number. Okay, if I run that thing, it'll ask me a bunch of stuff from before. And there you go, random number 3. So if you keep running the program, it will generate random numbers between 1 and 6. Sometimes it will generate the same number a couple of times just to mess with you. So don't be surprised if you run it and it goes 3 again. and then it does a 3 again, and then it does a 3 again, and then it does a 3 again, and then it'll start making them random. You know, don't expect them to be truly random. These are pseudo-random numbers. So real random, I mean, why is it a pseudo-random? Because we wrote some program which generates the random numbers according to some fixed by me algorithm. Maybe it's based on the system time. Maybe it's based on something else, but it's not a real random thing. You want a real randomness, you got to look at, like, you know, subatomic levels, like particles colliding and maybe wind moving around and stuff. Okay? So we don't get this. That's not what this is. All right? But it's close enough for what we're going for. It's a random number. Okay? All right. So now you know how to make a random number. And by the way, why don't we go and check to see if the number is odd or even? All right? I'm going to go in there, copy this, and I'm going to go with the random number. All right? And I can tell you if that is odd or even. Or the program is going to tell me. Oops. All right, so our random number is 6, and the number is even. I accidentally went in there and entered a 1. Okay, but whatever. Okay, so this piece of code works just as expected. It checks to see if the number is odd or even. Right? I can also check to see if something's positive or negative, which we did, you know, in here. Right? Checking to see if a number is negative. Okay. All right, so let's have a look at what do you have to do for this week or this Friday. So you have a couple of assignments. First one is user height message, right? So this should be pretty straightforward because you have already, you know, you already saw plenty of examples, right? How is this going to work? You're going to ask the user to enter their height, right? You already have to do conversions from feet and inches to total inches. Same thing, but now based on the total inches final thing, you're going to tell them some kind of a message, right? You can go ahead and insult the user, insult yourself, I don't care, right? Make it interesting, right? Tell them they're too tall, they're too short, they're just average, whatever, okay? If you get stuck, I kind of give you the freaking solution almost, so that will get you started. Try not to look at these, okay? Do not look at my hints on the bottom, okay? It's really not doing you a favor. So try to crack your heads on this for as long as it takes so that you can solve the problem. And definitely don't go online Googling things, okay? It's really annoying. Why? Because you're not learning the problem-solving skills, okay? When I took programming in 1999, believe me, the internet wasn't what it was today. You couldn't just go on Google things. There wasn't Google, first of all. Okay, so what did that force me to do other than write my programs on paper? I was walking around the streets thinking about these problems, and the more I thought about them, the better I got at them, right? So many years later, when I came back to teaching computer science, I was actually even not sure, like, man, did I still got it? Oh man, I had it. It was just like locked into my brain. But the only reason was because I did not rely on somebody else to do the thinking for me. I forced myself to, like, hit the wall, and then overcome it myself. And that's what real world programming is. You're going to get some completely unique problem, and there's not going to be anybody to help you solve it. There might be some clues on how to do different things, but the big problem solving thing has to come from you. Okay? So don't look at my solutions unless you really get stuck for a long time. Okay? You know, I expect you to get stuck in the beginning, which is why I give you these breadcrumbs in the beginning. Okay? But they'll start disappearing. Okay, so that's the first one, the height message. You ask the user for some information, tell them how tall they are. Second one, very similar. You're going to ask the user to enter a letter grade or a percentage. So they're going to enter their grade in percents. You're not going to ask them to enter percent. They're just going to enter a number like 90 or 80 or 75 or whatever. Okay, and based on that number, you're going to tell them what their letter grade is. So they enter a 75, you tell them a C. Why? Because this is your grading criteria. So how is this going to be written? You can have an if A is greater than or equal to 90, then an elif with an and in there. And you can notice that a lot of times, you know, that you just have to follow the logic of the problem. So if B is greater than or equal to 80 and B is less than or equal to 90. Right? So that's this. What else do I want to tell you? And it's, again, on the bottom I have some breadcrumbs for you just to check to see if, oh, does it say about, yeah, that's it. Any questions for this? Okay, next one. Number 11, the rock, paper, scissors. And this is the reason why I introduced random numbers. So this one, you could do it without a random number. The way it works is you ask either player to enter either numbers 1, 2, 3, or rock, paper, scissors, just one or the other. Just decide in advance for your own program. However you want to do it, it's your choice. Okay? And you hopefully know how the thing works, but if you don't know how rock, paper, scissors works, paper beats rock, rock beats scissors, scissors beats paper. So this beats this beats this beats this. All right? And then, of course, you have a tie. If they're both equal, nobody wins. Okay? How are you going to do this? Well, one enters. Let me just give you like a little, do I even have it with random numbers in there? Yeah, I show you how to make a random number. Yeah. So here's an example. So you can make a random number. You can have one of the players be equal to that random number. Okay? Maybe you can even have both of the players equal to the same random numbers. And then, of course, what you want to do is you always show yourself the values. So before you even check to see who's winning or whatever, show yourself player 1 is 1 or player 2 is 3 or something, right? And decide what these different numbers are going to mean. I suggest you make some variables, like rock is going to be equal to 1, paper is equal to 2, scissors is equal to 3. That will simplify the thinking when you write the code. So that later on, when you write these conditions, you're going to write things like, okay, well, remember, we had all the way on top, rock breaks scissors, right? So if I go in there and the first one is, let's say my player 1 is rock, right? If player 1 is rock and player 2 is scissors, that means that player 1 wins because rock breaks scissors, right? So that's how you do it. Of course, you don't have to say player 1 is equal to rock and player 2 is equal to scissors. You could say player 1 is equal to 1 and player 2 is equal to 3, which will work just the same, but it will be extra difficult for you to keep track of what the hell is 1 and what is 3, right? Just call them what they are. Remember, if it will help my logic later down the line to make these 3 extra variables, I'm going to do it. I'm going to minimize my thinking. I'm going to reduce the complexity of my program, so I'm making it simple and stupid. Keep that in mind. Okay? And then, so you're going to have 3 cases from when player 1 wins. So player 1 can win if it's paper, if it's rock, or if it's scissors. And you're going to have 3 the same exact cases when player 2 can win. Player 2 can win and when it's paper or rock or scissors. And then technically you could have 3 extra cases when they're tied. Paper is equal to paper, rock is equal to rock, scissors is equal to scissor. But you could also say just player 1 is equal to player 2, and that basically summarize all of them. Okay? And I have some breadcrumbs on the bottom in there for you to see, I wrote a couple of cases for when player 1 can win, and then one case from when player 2 can win, and I leave you the type for yourself. And again, don't look at my solution. What you should be able to do is, the problem-solving skills that you should acquire is you read a problem, and believe me, these problems that I have written up for you are 10 times easier than these retarded textbooks that you can buy for like $120. Okay, trust me. Like some of these assignments that I give, they used to be in a textbook, and they used to be like half a page, poorly written, and you could summarize it very neatly with what I have done. But don't expect that in real world. Expect to face things that don't make sense, especially when you work with customers who want you to write software for them. They don't know anything. It's the hardest part is to figure out what they want. Okay? So that's the problem-solving skill. Okay? And I think that's it for this week. Okay? So 3 more assignments, 9, 10, 11. And we're done with this. If you don't have any questions, let's get started and let me know if you need help.
that you posted.
Huh?
The thing that you posted about not having to come in class. So I'm thinking about picking up more hours at work for Monday and Friday. Is that going to work if I can only come in on Wednesdays as long as
You can keep up, man, that's fine. Yeah.
Okay. So my main concern with that is I can't be switched to an online.
You don't have to.
Okay,
Yeah, we're
'cause
good.
it's the GI Bill thing.
No, I'm not gonna switch you or anything. Yeah, you're good.
Okay. So I'll be here every Wednesday.
Okay, sir.
Awesome.
Sounds good.
Thank you.
See ya. Yeah. 1 second.
I'm getting an error. And the error I'm getting is not zero.
Okay. Let me see it.
Did you find that then?
Huh?
Did you find a file?
I couldn't find one that's legal in California. Huh?